Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that the Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous lecture we started with the basics of multi-stage amplifier. So initially I told you why do we need multi-stage amplifier. It is to increase the gain and to satisfy the requirements of input and the output resistance. And later on I told you we can cascade either non-interacting stages. When we cascade non-interacting identical stages, the gain is raised to the power n. But at the same time, the lower cutoff frequency becomes FL divided by 2 to the power 1 by n minus 1 under root, and upper cutoff frequency becomes FH into 2 to the power 1 by n minus 1 under root. So we say that gain increases and bandwidth reduces. Similarly, when we cascade interacting stages, in that case I told you the gain is the ideal voltage gain into the input resistance of second stage and output resistance of first stage. That is a factor of voltage division that we have to apply in multiplication to the voltage gain. And then we saw that there are three types of coupling. The first coupling was RC coupling. In this the benefit was that Q point is stable, but the disadvantage was poor low frequency and high frequency response due to coupling capacitor. Then we saw direct coupling. The disadvantage was Q point was unstable, but it has good low frequency response. And at last we saw transformer coupling, which is mainly used in output stage, and it makes the circuit bulky, but it can be used in impedance matching. So in this video what we are going to do is we are going to take a look at some of the connections which are used in multi-stage amplifier. So I'll focus on two connections. One is the cascade connection and other is the cascode. So first let me start with cascade. Now cascade connection refers to common emitter amplifier. That is, I am using two stages and both stages are common emitter amplifier. See this one, this circuit. This actually will be CC1. This is CE1. Okay, this is C. So if you see this much, only this much, this is your first stage. It is an example of common emitter amplifier. This resistance is RC1. Then if you see, we have used a coupling capacitor C2, and the next stage is also a common emitter amplifier. So which coupling we are using here? We are making use of RC coupling. The benefit of RC coupling is that the Q point is stable and the Q point of each stage can be designed independently. It does not depend on the next stage. Okay. So now when you want to design the AC model of this circuit, then what will happen? Suppose if I design the AC model, this is RS, then you will ground VCC. When you ground VCC, this R1 and R2 will come in parallel. This will be R1 parallel R2. Then due to bypass capacitor, due to the C1, RE1 will be grounded. So ammeter will be grounded. Between base and ammeter we will have a resistance R pi. Okay. And the voltage across it would be V pi. Then we will have a current source. This current source will be GM1 V pi 1. 1 because it is first stage or the first transistor. Then it will be in parallel with R0. Then due to this ground, this RC1 will be connected between collector and ground. This is your RC1. Then there is this coupling capacitor. I am showing it separately, CC2. Then there is again a transistor. Due to grounding of VCC, R3 and R4 will be in parallel. This is R3 parallel R4. Then again there will be a resistance R pi 2. Due to bypass capacitor, ammeter of second transistor is also grounded due to this capacitor. Then we have a current source GM V pi 2. Then we have a resistance R0 2 and finally RC2. This resistance is RC2. Also there will be one more resistance RL. Is it fine? So these are the resistances that are connected in this circuit. Now if I ask you the input resistance of the first stage RI1, the input resistance of first stage is actually equal to R1 parallel R2 parallel R pi 1. Now what about output resistance of first stage? If you see output resistance from here, output resistance from first stage will be R01 parallel RC1. This resistance I am calling as R01. What about second stage? What is the input resistance of second stage? The input resistance of second stage is R3 parallel R4 parallel R pi 2. What about output resistance of second stage? In that we don't consider the load resistance, so it will be simply RC2 parallel R0. Okay, don't consider RL when we are talking about the output resistance. Is it fine? Now what I can do is I can show this cascade connection in terms of block diagram, like the voltage gain of first stages are AV1, the input resistance RI1 and output resistance R01. Then the output of this stage is connected as an input of the second stage. The voltage gain of second stage is suppose AV2, input resistance RI2, output resistance R02. Then we have a load resistance RL here and we have a source resistance RS here. Okay. Now suppose I want to find out the voltage gain V0 by Vs. For that first I will find out the voltage gain of individual stages. A1 will be AV1 into, we have to take a factor of voltage division. Voltage division between input resistance of second stage and output resistance of first stage. Similarly A2, it will be voltage division between the load resistance and the output resistance of second stage. So what about total gain? Total gain will be A1 into A2, and also we will take a factor of voltage division between these two resistances RS and RI1, because there will be a voltage drop across RS also. Okay, so that will be the overall voltage gain. Is it fine? So what are the advantages of this cascade connection? Advantages is large gain, because the gain is being multiplied. Moderate input resistance, it is not very high but moderate. And the design is very simple. We have to take multiple common emitter amplifier and then connect output of first one as an input of the second one. What about drawbacks? What about drawbacks of the common emitter amplifier? Now since the gain is large, the bandwidth will become small. I told you why bandwidth is important, because it represents the range of frequencies which can be satisfactorily amplified. Then poor efficiency, then poor low frequency and high frequency response. Okay, that is due to this small bandwidth. So these are the drawbacks when we talk about cascade connection. The major drawback is its small bandwidth due to large gain produced by common emitter amplifier. Okay. And always remember, when I talk about input resistance of the overall amplifier, that is equal to input resistance of the first stage. And when we talk about output resistance, we take output resistance of the last stage. So input resistance is always defined by the first stage and output resistance is always defined by the last stage. Okay. So these things you have to remember when we talk about cascade connection. Let us go to the second connection, which is called as cascade amplifier. Cascade means the first stage is common emitter and the second stage is common base. Now both stages are not identical. One is common emitter and common base. Why we call it as cascade? Cascade here implies wide band amplifier, means the bandwidth of this amplifier would be high. So we are trying to remove the drawback that we obtained in case of cascade connection, and that is why we are going for cascade connection. Now for common emitter stage, if I talk about hybrid model, that is H parameter model, how you will draw the H parameter model? The H parameter model will be like this. HIE, then HFE into IB. Okay, and then in parallel to this will be 1 over HOE. Now what about common base? If we draw the common base hybrid model, in common base this resistance will be HIB, then HFB into IE, this is IE, okay, and then in parallel with 1 over HOB. Okay, I told you the H model remains the same, just the name of the parameters always changes. So this current here is collector current IC, this here is collector current IC. Now if I talk about the parameters of each stage, okay, so first of all tell me about current gain. The current gain of common emitter is HFE, okay, that is the current gain. Now what about the current gain of common base? Current gain of common base is minus HFB. Why? Because if emitter current is entering the amplifier, the collector current should leave. If collector current should leave, the gain will be shown as negative. Now this is actually equal to alpha. Now what is the value of alpha? Alpha is beta over 1 plus beta. So it is HFE over 1 plus HFE. That is your current gain. HFE means beta. So alpha is beta over 1 plus beta. Okay. Now the input resistance. The input resistance, if you see in this circuit, it is equal to HIE. What about in this case? The input resistance is HIB. Now see, in this resistance HIE basically is equal to R pi, which is 1 plus beta RE. So I told you when base current is flowing in the resistance is 1 plus beta RE. But when ammeter current is flowing, the resistance is simply Re. So this resistance is actually equal to HIE over 1 plus HFE. That means I have to divide this resistance by 1 plus beta, and then I can get the value of HIB. What about other parameters? What about the voltage gain? For voltage gain, you can see this current will go like this. Okay. So if you ignore HOE and you consider another resistance like RC, so what is the voltage gain? The voltage gain will be negative. So what is the voltage gain? Minus HFE IB RC. What about the input voltage? The input voltage is nothing but IB into HIE. So it is minus HFE RC by HIE. Okay, that is the voltage gain of the common emitter amplifier. In a similar manner, if I find the voltage gain of the common base amplifier, then also I will consider one resistance here. That will be RC. Since the circuit is same, the voltage gain will also be same, but the name of parameters will be different. Minus HFB RC by HIB. So the circuit is same, so the gain is same, but instead of E I am using B because it is common base. Now if you replace the value of HFB in terms of HFE and HIB in terms of HIE, so it will become minus HFE RC by HIE, because this factor of 1 plus HFE will get cancelled in both the HFB and HIB. What about output resistance? In this case 1 by HOB. What about output resistance here? 1 by HOE. So these are the parameters for common emitter and common base amplifier, and what I have done is I have cascaded both the amplifiers, or I have connected the output of first amplifier as the input of the second one. Okay. Now see what happens. I'll remove this. See what happens. The input resistance of second stage will work as the output resistance of the first. What I mean to say is Ri2 will work as RC for first stage. Okay. And this suppose is load resistance, then that means RC2. Let me write RC1 here and RC2 here. And RC2 then will be equal to RL for second stage. That means if I write the voltage gain of the first stage, I will write minus HFE, then Ri2 upon HIE. The voltage gain of second stage minus HFE RL over HIE. Okay. And the overall voltage gain can then be written as the product of AV1 and AV2. So it will become HFE square Ri2 RL over HIE square. Now this Ri2 is basically HIE over 1 plus HFE. We derived just now. Okay. So it will become HFE square over 1 plus HFE into HIE into RL. Now 1 plus HFE is approximately equal to HFE. So it will be HFE by HIE into RL. Okay. So if you want to further simplify this expression, what you will have to do is, what you will be doing is, 1 minute, actually this will be positive because minus HFB will become positive. HFB is negative, so minus HFB will be positive. So if this is positive, this gain will be positive, this overall product will be negative, negative, negative. Now HIE, I told you it is 1 plus beta RE, or you can say 1 plus HFE into RE. Beta is HFE. So So this voltage gain overall is minus HFE RL over 1 plus HFE RE. These are approximately same. So it is minus RL by RE. The voltage gain being negative means there is a 180 degree phase shift between the input and the output signal. Okay. And the voltage gain is approximately equal to the voltage gain of a common emitter amplifier. That means the entire voltage gain is being provided by the common emitter amplifier. Now, this is the practical circuit of cascade amplifier. The circuit that I just showed you was conceptual. It was not practical. Now we take some assumption while analyzing this cascade amplifier. First, I'll try and perform the DC analysis. Okay, I want to perform DC analysis. For that, I assume that beta is high. I told you whenever you see beta is high, you take base current to be 0. So this base current will be 0. In DC analysis, your capacitors will be open. Okay. Now see, if you see this thing, the input voltage is connected to the common emitter amplifier, and then the output of common emitter amplifier is input to the common base amplifier, and output is taken from common base. That is why it will be called as cascade amplifier. The input should be connected to common emitter and the output should be taken from common base. Now when you open circuit this capacitors and base current is 0, the current will be same in R1, R2 and R3. Now what will be this current? This current will be VCC over these three resistances are now in series, R1 plus R2 plus R3. Now based on this, if you want to find out the base voltage of transistor 1, this is VB1, this is VB2. So base voltage of transistor 1 can be found out as how? By voltage division, VCC, or you can write KVL VCC minus IR1. So it will come out to be VCC into R2 plus R3 over R1 plus R2 plus R3. Similarly, you can find out base voltage of transistor 2 as the voltage across R3. So VCC into R3 over R1 plus R2 plus R3. So these are the two base voltages. Now if you want the emitter voltage, it will be base voltage of transistor 1 minus base emitter drop. Okay. Similarly, emitter voltage of transistor 2. Emitter voltage of transistor 2 is actually base voltage of transistor 2 minus base emitter drop. Now this capacitor will be open. So based on VE2, you can find out IE2. IE2 is actually VE2 by RE. VE2 means emitter voltage of Q2. If you divide it by RE, you get IE2. Now since we know one thing, since base current is 0, emitter current is same as collector current. So this is also equal to IE2. This is also equal to IE2. So what we can say, IC1 is equal to IC2. Collector currents are same as the emitter current. Okay. Now if you want in Q point, if we want in Q point the collector to emitter voltage, how you will find that? See, this voltage is basically VE1 and this voltage is VE2. So if you want to find collector to emitter voltage of 2, this voltage, so the positive terminal is connected to emitter of Q1, so its voltage is VE1. The negative terminal is connected to emitter of Q2, its voltage is VE2. So what I am saying is voltage of this terminal is VE1, voltage of this terminal is VE2. What about the first transistor then? For that we need the collector voltage VC1. VC1 will be VCC minus IE2 into RC. So I am taking the voltage drop across RC to find VC1. Then how you will find VCE1? It will be VC1 minus VE1. So once we have found out the collector current and the collector to ammeter voltage, we have obtained the Q point of each stage or of both the stages. Why Q point is important? Because when we are modeling it as an amplifier, we will need the data of Q point and then only we can find the parameters of amplifier. Now let me remove all the markings on the figure. What I will do now is, I will form the amplifier model. For amplifier model for AC analysis. Now we will proceed to AC analysis. For AC analysis, what we will do? We will ground VCC and the capacitors will be short circuited. So see, this capacitor will ground the base of Q1. So base of Q1 will be grounded. So let me draw Q1. This is Q1. The base is connected to ground. Okay. So I have connected the base to the ground, but its ammeter is pointing towards Q2. So let me do one thing. I'll mark this terminal as ammeter. It will be connected to Q2. Okay. Now see, the ammeter of Q1 is connected to collector of Q2. So the ammeter of Q1 is connected to collector of Q2. This is your Q2. The collector of Q2 is connected to ammeter of Q1. Okay. Now see, this ammeter resistance of Q2 is grounded through this capacitor. So this ammeter terminal of Q2 will be grounded. Okay. Now see, the base of Q2 is connected to Vin. The base of Q2 is connected to Vin. Now let us talk about these resistances R1, R2, R3. R2 is connected between base of Q1 and base of Q2. Base of Q1 and base of Q2. R1 is connected. Sorry, R2. R3 is connected between base of Q2 and ground. Base of Q2 and ground we have R3. Now see this. VCC will also be grounded. Now this base is grounded and this terminal is also grounded. That means this R1 is short circuited because both the terminals of R1 are connected to ground. What about R2? R2 is connected between base of Q2 and ground. So R2 is connected between base of Q2 and ground. This is R2. Are you getting my point? This terminal of R2 is connected to base of Q2. This terminal is connected to ground. What about R1? This terminal is grounded and this terminal is also grounded. So R1 is shorted. What about RC? RC is connected between collector of Q1 and ground. Collector of Q1 and ground, we have a resistance RC. And this is connected to V0. So once we have this model, what I'll do is, I'll replace BJTs by their models. Okay. So how you will do that? Let us see here. This is V in. It is connected in parallel to R2 and R3. So R2 and R3 will come in parallel. Then we know that between base and ammeter of Q2 we will have a resistance R pi. This will carry a current IB. Either you can use GM V pi model or beta RE model. Okay, it is your choice. You can use any model, either the T model of BJT or hybrid pi model. Now this is the ammeter terminal which is grounded. Let me call it as IB1. Then we will have a current gain beta IB1. Now this beta IB1, suppose I am ignoring R0. Now I have to draw the model of this common base amplifier. This is common base, this is common ammeter. Now if you show resistance in the ammeter circuit, this is ammeter circuit. If you show resistance in the ammeter circuit, the resistance must always be RE. Okay, the resistance must always be RE. If we show the resistance in the base circuit, it is 1 plus beta RE, or you can say R pi. So this is the ammeter terminal of second one, and this will be the base terminal of second. Now base terminal is grounded. What about collector terminal? Between collector and base, we have a current source. Now this current source is either beta into IB, or you can say alpha into IE. Either you can write beta into IB or alpha into IE. Then this is your collector terminal. Now collector is connected to resistance RC and ground. This is your V0. Okay. So let me again tell you how I have drawn this model. So first what I have done is I have drawn the model of this common ammeter amplifier. So this is the base terminal. Okay. Sorry, this is the ammeter base terminal, right? This is the ammeter terminal, and this is the collector terminal. Now collector of Q2, suppose I call this as IB2, because transistor naming is like this, IE1. Okay, beta IB2. Now see, the collector of Q2 is connected to ammeter of Q1. So I have shown in the ammeter circuit a resistance RE. Then I have grounded the base terminal because base of Q1 is grounded. Then between collector and base I have shown a current source which can be written as beta IB, or you can also write it as alpha IE. Okay, there can be two methods of writing the current source, beta IB and alpha IE. Then I have reached the collector terminal, and collector is connected to resistance RC. Now the first thing that I'll derive is the voltage gain. Okay, AV. This I'll write as V0 by V in. Always remember one thing that I have used in designing the model. If you are showing ammeter, if you are showing the resistance between base and ammeter carrying a current IB, the resistance will be beta RE. If the resistance carries a current IE, then the resistance will be simply RE. Now if I want to find this IB2, how you will write IB2? IB2 will be simply V in over R pi. Okay, this is your IB2. This will make current beta IB2, which is equal to IE1. So by KCL I can say IE1 is beta IB2, which is beta V in over R pi. Now the current source here is alpha IE1, which is flowing like this, plus minus. So what you will write? V0 has opposite polarity, so minus alpha IE1 into RC. So that means minus alpha beta V in RC over R pi. So what you can write? V0 by V in is minus alpha beta RC over R pi. Now R pi is nothing but beta RE. So minus alpha RC over RE. Since alpha is approximately equal to 1 if beta is very high, because it is beta over 1 plus beta, so the voltage gain is approximately minus RC by RE. This I derived earlier also. Okay, in cascode connection I showed you that the voltage gain is approximately minus RC by RE. Next let us talk about input resistance. Okay, let me talk about input resistance. The input resistance, if you see from this figure, what is the input resistance? The input resistance is same as the input resistance of first stage. So what I'll write, Ri is how much? Ri is equal to R2 parallel R3 parallel R pi. Okay, these three resistances are in parallel. Now let us talk about current gain. AI. See, the output current will be something like this, I naught. From here what you can say, I naught is minus alpha IE1. And this will be the input current I in. So if you want to find out I naught by I in, so it is minus alpha IE over I in. Now IE is actually equal to IE1. IE1, if you see in this circuit, this IE1 is equal to beta IB2. So beta IB2 over I in. Now how you can find IB2 here? If you want to find out IB2, you can apply current division. I in into R2 parallel R3 by R2 parallel R3 plus R pi. So that way, by applying current division, I can write IB2. It is I in into R2 parallel R3 by R2 parallel R3 plus R pi. If you substitute this expression of IB2, I in will get cancelled. So it will come out to be minus alpha beta R2 parallel R3 over R2 parallel R3 plus R pi. Okay. So that means if alpha is equal to beta over 1 plus beta, so alpha is approximately 1. So you can say minus beta R2 parallel R3 over R2 parallel R3 plus R pi. Okay, I am taking alpha is approximately equal to 1 if beta is very high. Then we will talk about output resistance. Output resistance, if you see this circuit, it is simply, output resistance is simply RC. Okay. These are the general parameters that we derive for any amplifier. But one more parameter that we will be deriving here, that parameter will be your transconductance. Okay. So I will derive transconductance. Okay, that is the most important parameter of cascode connection. Remember, from exam point of view, the most important parameter that can be asked is transconductance. Now, how to find transconductance? It is basically ratio of a output current by input voltage. Here the output current is from the second stage or the common base. Okay. So what is the output current here? It is alpha IE1 or you can say IC1. IC1 by V in. IC1 is actually equal to alpha IE1. This is the output current, alpha IE1 by V in. Now this alpha IE1 was equal to I beta IB2 by V in. Now this IB2 can be written as V in over R pi. So it is alpha beta over R pi. That means alpha into GM1. Beta over R pi is actually GM1. Since alpha is approximately equal to 1, this will be equal to GM1. Remember, transconductance is nothing but HFE over R pi. That is beta over R pi. So that means the transconductance is approximately equal to the transconductance of the first stage or the common emitter amplifier. Okay, that is GM of common emitter amplifier. That is your first stage. Now, what are the advantages of this cascade amplifier? The advantages are it has a large gain, because I told you the gain is approximately that of a common emitter amplifier, and common emitter amplifier has a large gain. It has moderate input resistance, but since it is cascade amplifier, it has a large bandwidth. So we have solved the problem of bandwidth, but remember, the gain of cascade will always be less than cascade. It is high, but it is not as high as cascade connection. So the gain is high and it has large bandwidth. So we have solved the problem of bandwidth. But what is the drawback? Drawback is it has a large output resistance. So if we summarize what we have covered in this lecture, so we have first studied common emitter, which we call as cascade connection. I told you how to find the voltage gain here. Then the most important thing that we have studied in this video is the cascade connection. I have told you how to derive the Q point. In this we assume beta as high and then we solve for Q point. And then we saw how we can draw the AC model. The input resistance was equal to input resistance of common emitter amplifier. The output resistance was equal to output resistance of common base. The transconductance was equal to transconductance of common emitter stage. The voltage gain was coming out to be minus RC by RE. Okay. And the current gain, it was minus beta R2 parallel R3 by R2 parallel R3 plus R pi. We saw in cascade connection bandwidth is low, but in cascade connection the bandwidth is large. So bandwidth problem of cascading is solved using the cascade connection. Okay. That means even after cascading multiple stages, we can use a common base stage at the output in order to improve the bandwidth of the amplifier. So cascade amplifier implies that it is a wide band amplifier. Okay. So this will be all from this lecture. In the next video, we will see one more connection for the multi-stage amplifier. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And Iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough, interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, It is 50 to 50 with code Ankit ESE. It becomes 45 to 25. And 2-year subscription becomes 66,600. So the choice is yours. But take a longer duration subscription for more cost-effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live, you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that, my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.